Hello everyone. Today we're going over the law of sines and the fundamental proportions that make up the properties. First off, we're going to use the law of sines in two general situations. If we have an angle, a side, and the opposite angle, or a side and two angles, or if we have two sides and an angle. Now, this first set, when we have two angles to work with, that's going to be our ideal circumstances because we'll know right off the bat if we have a proper triangle or not. If we have two sides but only one angle, we end up with an ambiguous case where we might have one triangle, two triangles, or no triangles. More on that later on. But essentially, I'm going to go through each problem, each of the following few problems, explain the process, explain the logic behind them, and finally solving out our answers. So the fundamentals is that the law of sines is essentially a proportion. That for any angle and its opposite side, there exists a proportion such that the sine of that angle over the opposite side will be equal to the sine of any other angle over any other corresponding side. And so if I can find or build an initial proportion, I can use that proportion to solve for any of my missing components. So first things first, example 1. We want to solve the following triangle knowing that angle A is 40 degrees, angle B is 60 degrees, and side A has a measurement of 4. I have a complete ratio in that angle A is 40 and side A is 4. So my base ratio that I'm going to use is the sine of 40 over 4. And since it tells me about angle B of 60, the first thing I'm going to solve for is side B. I'm going to take my initial proportion and set that equal to the sine of 60 over side B. And just like any sort of equation, we're going to rewrite our equation to isolate our variable, in this case our B. And if we do that, we'll end up with B, side B, is equal to 4 times the sine of 60 over the sine of 40. Pop that into our calculator, and we'll get our B measurement equal to about 5.3 units. Now that I have my B side figured out, it's time for us to move on to our C's. To find our angle for C, we need to remember that a triangle has 180 degrees internally. And I know I have an angle of 60 and an angle of 40, which means that whatever's left is my angle measurement for C, which means that C is equal to 80 degrees. This then allows me to take my initial ratio, my sine of 40 over 4, and set that equal to find my C length, the sine of 80 over C, which after we rewrite and solve, will give us a C value equal to about 6.1 units. So we start off with an angle, and a side, and we ended up solving for an angle, a side, and a side. We're going to do a similar thing in this case. We have a known angle of 38 degrees, another known angle of 64 degrees, and a known side of 9 units. And I know that I have a potential ratio here because I have both the angle and the opposite side for my B's. So the equation that I'm going to use, or rather the proportion that I'll be building off of, is essentially the proportion that the sine of B, or the sine of 64, over 9. So working from that, I know that my angle of C is 38, so I can use my angle of C and my proportion to find my little c, my length of c. So, set up my equation. I've got the sine of 64 over 9 must be equal to the sine of 38 over little c. Rewrite the equation to isolate my c and solve it. My c value ends up being about 6.2. Just like before, to find my angle for A, I know that my triangle has 180 degrees, and I know I've got a 64 degree, and I know I have a 38 degree, so whatever's left has to be my measurement for A. Well, 180 minus 64 minus 38 is going to leave me with 78 degrees. So to find my opposite side A, I'm going to do my sine of 64 over 9 is equal to the sine of 78 over little a. Rewrite and solve. Our a ends up being equal to approximately 9.8. And if you need me to go through the individual steps, let me know via email. Happy to assist. All right, third example. In this one, we change things up a little bit, but not too much. Because we have angle A, angle B, and side C. So we don't have a full ratio set up, but we can find one. Because essentially, I can use the fact that a triangle has 180 degrees, and that I'm given a 35 and I'm given a 15, tell me that whatever's left over is going to be my C angle at 130 degrees. So now I have a ratio I can use such that the sine of 130 over my known C of 5, I can then use that to find my A and my B. So we'll do A first is equal to the sine of 35 over A. Plug and chug. A becomes equal to 3.7. And then for our B, the sine of 130 over 5 is equal to the, different colors, the sine of 15 over B means that B has to be equal to about 1.7 units. And that's that. Now for the ambiguous cases. If you recall, going back to the unit circles and inverse functions, if I were to ask you for sine theta equals 1/2, to solve that we'd have to use the inverse sign. So essentially, for what angle theta do we have 1/2 as a sine value? In the unit circle, being, well, a circle, there exist 2 points on that circle that have a sine of 1/2, which means there are 2 angles that will make this a true statement here in purple. Because we only have one angle that is known in this ambiguous case, we have to check both potential angles in order to determine if we have one possible triangle, 2 triangles, or no triangle at all. We have 3 more example problems. The first one will be a 1-solution problem, the second one will be a 2-solution problem, and the third one will be a no-solution problem. I will go through and explain the logic behind each one, as well as how we are working them. So, example 1, the 1-solution problem. We know that the side A is 3, side B is 2, and angle A is 40. Which means I have a ratio to work with. Actually, let's put this here. I have a ratio to work with built off of the sine of 40 over 3 as my base ratio. I'm going to use that to solve for my angle of B. So my equation is going to change a little bit now, such that I have the sine of 40 over 3 is equal to the sine of B over 2. Simplify and rewrite this problem. I'm going to end up with the sine of B is equal to 0.42, which means that somewhere in my unit circle there exists a sine, a y value, that is going to be about 0.42. There are going to be exactly two of them because our y values are positive in the first and second quadrants. So to figure out what my angle B is, I'm going to use my inverse sine function, take the inverse of both of these statements such that I have B is equal to the inverse sine of 0.42. And you can just chuck that into the calculator. No need to do it out by hand. And you'll end up with B, we'll call it B1, is equal to 25.4 degrees. Now the reason I call it B1 is that even though I've told you this problem will only have one solution, in an actual problem you might not know if it has one solution, two solutions, or no solutions. So it's important to label them as B1 and B2 in order to distinguish between them. Now, what do I mean by B1 and B2? Well, take a look back at our unit circle. That angle there would be our 25.4 degrees. The way we essentially got that is we're going 25.4 degrees above our 0 mark, our 0 degrees. This angle here is going to be 25.4 degrees above, quote unquote, the 180 degree mark over here, such that we get this angle there. But even though I said above, we're actually going to find that by subtracting. So we'll do 180, this line here, minus that angle measurement there of 25.4, which would give us 154.6 degrees. So that's our B2. We'll solve B2 momentarily. Let's go back to B1 and focus on B1. If B1 has an angle measurement of 25.4 degrees, then I can use that to find my C value, which I'll call C1. And C1 is going to be equal to 180 minus my known angle of 40 minus my B1 angle of 25.4, give me a C value of 114.6 degrees. I'll then use that potential C value in conjunction with my original proportion, the sine of 40 over 3, which would be equal to the sine of 114.6 over the side C, to give me essentially that side C is equal to 4.6 0.2 units. And so we've solved for one triangle here. We've solved for our missing angles as well as our missing side. Now let's go back to this B2. The way we're going to verify that this only has one solution is by examining B2. Specifically, we need to figure out what angle C could be if B2 is 154.6. The way we'll figure out what angle C2 could be, so angle C2, well, we have 180 minus the angle that we know of 40 minus B2, 154.6. And that's going to give us our potential C2 angle. Here's the thing though, we're going to end up with negative 14.4-ish degrees. Triangles can't have negative degrees. So because this potential B angle implies the existence of a negative C angle, we can discount it and say that no, it's not actually a possible solution. We only have the one solution on that side of the orange line. So that's how we use law of signs with the ambiguous cases to identify one solution. This problem is going to have two solutions. We know that we have a known angle of 35 degrees. Opposite to it, a known side of 6 units, and a known side of 8 units underneath angle B. So the proportion that I'm going to be using is the sine of 35 over 6. So the sine of 35 over 6 must be equal to the sine of B over 8. If I solve this out, I'll get B1 equal to 49.9 degrees. If B1 is 49.9 degrees, then C1 will be 180 minus my 35 minus my 49.9, which puts C1 at about 95.1 degrees. If C1 is 95.1 degrees, then I can use my initial ratio, the sine of 35 over 6 is equal to the sine of 95.1 over small side c. Solve that one, and I end up with small side c is equal to 10.4 units. That's one possible solution. To find my second solution, I need to remember that my unit circle has two potential B angles. One of my B angles here is 49.9 degrees above the zero. To find the corresponding angle over here, I'm going to take my 180 and subtract that 49.9, get that other angle, such that B2 is going to be 180 minus 49.9, which means that B2 is essentially equal to 130.1. 130.1, it's a positive angle, so it could still be a triangle. We're going to keep working until we find proof that it's not a triangle or until we finish the triangle. So if B2 is 130.1, I need to solve for, potentially, C2. And C2 is equal to 180 minus my known angle of 35 minus my potential angle of B2, so 130.1, which means that C2 is going to be equal to 14.9. 14.9, that's a proper angle, so I'm going to keep working. And I'm going to use that measurement there, that angle of 14.9 in conjunction with my original proportion, my sine of 35 over 6, to solve for my unknown c value, little side c, such that the sine of 14.9 over c means that our potential c value, our potential c side, would be 2.7 units. So this has two solutions because our two potential b angles both create viable c angles to work with. If we have viable c angles, we can solve for our missing third sides of c. All right, last one. And as I mentioned, this one has no solution. And I'll explain why. If we look at the problem, we have a known side of 2, a known angle measurement of 50, and a known side of 1. So the ratio that I'm working off of, and its ratio quote unquote, is the sine of 50 over 1. And anything over 1 is essentially itself. I'm going to use that to solve for, or try to solve for, my angle A, because I have an opposite side of 2 that I can work with. So my equation will essentially be my sine of 50 over 1 is equal to the sine of A over 2. If I toss into a calculator, I'll get 0.77 is approximately equal to the sine of A over 2. Multiply both sides by 2 to get rid of that fraction, and I get 1.53 approximately equates to the sine of A. Now if you stick this into your calculator and do the inverse sine of 1.53, you're going to get met with an undefined statement. And this is essentially because if you take a look back at our unit circle, our unit circle's highest sine value is positive 1. Our unit circle's lowest sine value is negative 1. So our potential to run an inverse sine check would only be for values that exist between negative 1, nope, let's not use theta, number that exists between negative 1 and positive 1. If we end up with anything like this that I'll outline in gray, where the sine of something exceeds, is lower than negative 1 or higher than positive 1, we're going to end up with an undefined situation. So because we have essentially an impossible angle to work with, because 1.53 is somewhere outside of our unit circle, we can't actually solve for it. So this would be a no solution situation. And that, folks, concludes the law of sine notes. If you have questions on anything, please ask. I'm happy to assist.